Hi everybody, in this video we are going to find the side lengths of right triangles. The first right triangle is going to have a hypotenuse of 1 and then angles of 30 degrees, 60 degrees, and 90 degrees. Then the second triangle is also going to have a hypotenuse of 1 but angles of 45 degrees, 45 degrees, and 90 degrees. And then we're going to use those side lengths to find some trigonometric ratios in an IXL exercise. So let's start out by drawing an equilateral triangle. I know I just said a right triangle, but bear with me. If I start with an equilateral triangle, I didn't draw that very well, but pretend all these side lengths are the same and pretend that they all have lengths of 1. Okay, and if it's an equilateral triangle, then all of the angle measures would be 60 degrees. Now that I have this triangle, what I'm going to do is I'm going to split it down the middle like this. You know what? I don't have to use dotted lines. Let's just use a straight line. Okay, now I have two right triangles. And if this side length was 1 before and I split it in half, then each of these would be a half. I'm going to erase this in a second, actually. So I'll just write a half over here. And if I took this angle, which was 60 degrees before, and I split it in half, then this angle and also this one would each be 30 degrees. Okay, so there, just like I promised you, there's my right triangle with a hypotenuse of 1 and angle measures of 30 degrees, 60 degrees, and 90 degrees. I don't need this anymore, so let me erase that. Okay, and then I can use the Pythagorean theorem to figure out the length of this side. So we have a squared plus b squared equals c squared. The hypotenuse is 1, so let's plug in 1 for c. And one of these sides, one of the legs is a half. So let's choose either a or b and just put a half in there. Okay, a half squared plus b squared. By the way, I put parentheses in here because if I had written it like this, then it would have looked like 1 to the second power over 2. That's not what we want. We want the entire fraction, 1/2, to be raised to the second power. And then let's just go ahead and solve this for b, and that'll be the length of this leg over here. So 1/2 to the second power means a half times a half. So in the numerator, 1 times 1 is 1, and the denominator, 2 times 2 is 4. And then plus b squared equals 1 to the second power is just 1 times 1, which is 1. Okay, then we can subtract 1/4 from both sides. And I ran out of space, so I'm going to continue over here. So we would have b squared equals 1 minus a fourth. A whole minus a fourth would be 3/4. Okay, and then finally take the square root of both sides, and we would get b is equal to the square root of 3/4. Now we can write this as the square root of 3 over the square root of 4, and the square root of 4 is 2. So we get the square root of 3 over 2, and that is the length of this side over here. Okay, now let's go ahead and figure out the side lengths, or the legs of a right triangle that still has a hypotenuse of 1, but now these angles are 45 degrees. So this is an isosceles triangle. These angles are the same. They have to be 45 degrees because if it's a right isosceles triangle, then one angle is 90 degrees, this one over here, then these two angles must be the same. So they have to add up to 90, and if they're the same, then they must be 45 each. Okay, and then we're just trying to figure out the length of these two sides over here, and we can call them a and b. So again, we can use the Pythagorean theorem, a squared plus b squared equals c squared. Okay, but A and B, if this is an isosceles triangle, right, it's a right triangle, but it's also an isosceles triangle, that means that A and B must be the same. So if I'll keep the A in A, I can replace the B also with an A because B and A are the same. So I have A squared plus another A squared is equal to C squared. Really, I could just have called both of these A in the first place, okay? So A squared plus A squared is 2A squared equals, oh, you know what? Now would be a good time to plug the 1 in for C. And then we're just solving for A. So let's divide both sides by 2. What do we have over here? 1 to the second power is 1, and then over 2. So we have just 1 over 2. And then take the square root of both sides. All right, so we would get A is equal to the square root of 1/2, which is, let me get back up into this white area here, not the gray area, so you can see it better. That's the same thing as the square root of 1 over the square root of 2. The square root of 1 is just 1, because 1 times 1 is 1. So we can write this as 1 over the square root of 2. Right, so that's A, but A is the same as B, right? And in fact, I erased the B over here a minute ago, and I replaced it with an A. So both of these sides have lengths of 1 over the square root of 2. Okay, so we are going to go straight to this IXL exercise over here, Pre-Calculus M7, find trigonometric ratios of special angles. You can see over here on the left, I've written the definitions of the trigonometric functions and some conversions of simple angles. 30 degrees is pi over 6 in radians, 90 degrees is pi over 2 in radians, and so on. And then these triangles, which we just did. So let's get started over here. Evaluate, write your answer in simplified, rationalized form. Do not round. Okay, so we have the sine of 45 degrees. So we're going to look at this triangle. Here's a 45 degree angle. Actually, we don't need to use, this one is superfluous here. It's redundant. We already have this 45 degree angle here. So anyway, sine is opposite over hypotenuse. So the opposite side is 1 over the square root of 2. And then we put that over the hypotenuse of 1. But anything divided by 1 is just itself. So this is equal to 1 over the square root of 2. So we're going to press this fraction button. And actually, what they mean by rationalized here is they do not want square roots in the denominator. So we're going to have to change this a little bit. Now, hopefully you'll agree that anything times 1 is itself. So if I multiply this by 1, then I'm not changing it. And hopefully you will also agree that any number divided by itself is 1. So instead of actually writing a 1 there, I could have written, let's say, 5 over 5, because 5 over 5 is equal to 1. So I'm still not changing the value of this if I multiply it by 5 over 5, because 5 over 5 is 1. But instead of choosing 5 for the numerator and the denominator, let's be clever about this. We can choose the denominator here, which is the square root of 2. And we can multiply this fraction by the square root of 2 over the square root of 2. Hopefully you'll still agree that the square root of 2 over the square root of 2, since I'm multiplying some number by itself, this fraction is equal to 1. And so this fraction times 1 is still equal to this fraction. But when we do this, we're not changing the value of it, but we are going to change the way it looks. So 1 times the square root of 2 is the square root of 2. The square root of 2 times the square root of 2. So let's think about that. The square root of 2 means the number that, when we multiply it with itself, gives us 2. But we are multiplying that number with itself because we have the square root of 2 times the square root of 2 here. So that should just be 2. So the square root of 2 over 2 is equivalent to this, but this would be in rationalized form because we do not have some messy square root in the denominator. So that's what we're going to write. I'm going to press the square root, 2 over 2. Okay, fantastic. Evaluate, write your answer in simplified rationalized form, do not round. Okay, so now we have the sine of 30 degrees. So remember again, sine is opposite over hypotenuse. For 30 degrees, we're going to look at this triangle. This is the angle that we're talking about. The opposite side is a half. I'm going to put that over the hypotenuse, which is just 1. Okay, so it's pretty simple. A half divided by 1. Anything divided by 1 is itself. So we still have a half. All right. The tangent of 30 degrees. Again, well, let's remember tangent is opposite over adjacent. This is the angle that we're looking at. The opposite side is a half. I'm going to put that over the adjacent side, which is the square root of 3 over 2. Okay, then we can do keep, change, flip. So this is the same as a half times the 2 over the square root of 3. These 2's cancel out, and we get 1 over the square root of 3. We're going to use that little trick that we did before, and we're going to multiply this by the square root of 3 over the square root of 3, which is just like multiplying it by 1. Now, 1 times the square root of 3 is the square root of 3, and the square root of 3 times the square root of 3 is 3. So our answer in rationalized form is the square root of 3 over 3. It's kind of fun when you get the hang of it. All right, next one, the tangent of pi over 3. Here's tangent, opposite over adjacent. Pi over 3 is the same as 60 degrees. See, I've put it all here for you, so no problem. So we're looking at the 60-degree angle of this triangle. Again, tangent is opposite over adjacent, so that's the opposite side of the 60-degree angle. Over the adjacent side would be a half. Keep, change, flip. These cancel. We get the square root of 3 over 1, which is just the square root of 3. The cosine of pi over 4. What's cosine? Adjacent over hypotenuse. Pi over 4 is the same thing as 45 degrees. So let's look at this triangle. So we want to find the adjacent side over the hypotenuse. Okay, so that's going to be 1 over the square root of 2 over 1. Anything divided by 1 is itself. So we get 1 over the square root of 2, multiply the numerator and denominator by the square root of 2. We get the square root of 2 over 2. Okay. And I just realized I'm basically doing that you should be doing. So maybe I should skip ahead a little bit. All right, the sine of pi. So sine is opposite over hypotenuse. Pi is 180 degrees. Now, we can't draw a right triangle with 180 degrees, right? So these pictures over here are no good to us. What we can do, though, is we can use that alternate definition of sine and cosine and tangent, and then the sine is just the y value of the point where the line meets the circle, remember? So it's a little bit different than how I wrote it up here. These are for the right triangles. But the other definition of sine is if I take a line starting here and I rotate it 180 degrees. So pi, that's in radians, okay? But pi is over here. That's 180 degrees is the same as pi radians. Okay, so this is the line that I'm looking at. Where does this line meet the circle? Right over here. Now, what would the y value and the x value be? Maybe I should have done this earlier, but that's okay. So this is the y-axis, and this is the x-axis. we're still going to say that the length of this is 1. Okay, so from here to here is 1. So this point, what point would that be? That would be -1, 0. So the sine of pi is just the y value of this point, which would be 0. Okay, so we're done. The tangent of pi. All right, so the tangent of pi, again, it's the angle is pi radians, so we're here again. So the tangent would be the y value divided by the x value. That would be 0 divided by -1, which is still 0. The tangent of 360 degrees. Now we're going all the way around the circle back to where we started over here. That's 360 degrees. Here, where the line meets the circle, would be at the point 1, 0. 1 for x, 0 for y. We want to do the y value divided by the x value for tangent. Well, 0 divided by 1 is, again, 0. All right, the tangent of 135 degrees. Let's do this, and then let's skip a level. I feel like I'm doing too much. I'll save some problems for you. So if I move over to 135 degrees, okay, then, so now actually we're going to go back to the triangles in a second. So 135 degrees, I'm going to turn this into a right triangle. And what would, if I'm at 135 degrees over here, so if this is 135 degrees from here to here, then what would this angle be? And remember, from here all the way around to here is 180 degrees. So to answer that, we would do 180 minus 135, which is 45. So this is 45 degrees. Okay, and so actually we could do this by looking at the triangle with the 45 degree angles in it. And that's what we will do. Remember that tangent, going back to these definitions, is opposite over adjacent. We're going to look at this triangle. The opposite side is 1 over the square root of 2. The adjacent side is also 1 over the square root of 2. If we do this divided by this, well, they're both the same. So this divided by this should just be 1. Anything divided by itself is 1. What? Oh, duh. Okay, yeah. So we were, oopsie. Let me go. That was silly. Okay, so we were on the left side over here. Okay, so really, we would have that if this side length is 1 over the square root of 2, and this side length is also 1 over the square root of 2, then this point over here would be, let me erase this for some space. Yeah, so what would that point be? That would be the point -1 over the square root of 2 for the x value, right, where I am on the x-axis. If this is the origin, then I'm at -1 over the square root of 2. For the y value, I'm still at positive 1 over the square root of 2. Okay, so the y value here divided by the x value would give us -1 because we have a positive divided by a negative. That was silly on my part. Okay. So, well, anyway, it's a good reminder just to read the explanation anytime you get anything wrong. And here, this is the same explanation that I gave you over here. They just wrote 1 over the square root of 2 as the square root of 2 over 2, which we talked about, right? Okay. So read through it if you get the answer wrong. Now let's click, got it. The cosine of 360 degrees. 360 degrees is going to put us back over here. The cosine is just the x value of this point. So this would be the point 1, 0. So the x value is 1. All right, let's go ahead and skip to the next level. Tangent of 2, let's skip again. This is same kind of thing we've been doing. Is it going to give me anything different? Okay, a negative. All right, so negative pi, remember that pi radians is 180 degrees. Okay, so if I start over here and then I go negative 180 degrees, that means I'm going clockwise instead of counterclockwise. Notice that for most of these I've been starting here and going counterclockwise. This is considered the positive direction for angle measures, and this clockwise is defined to be the negative direction. This is positive, this is negative. So if I go 180 degrees this way, really it's just going to put me at the same place as if I had gone 180 degrees counterclockwise. So with 180 degrees or pi radians, it really doesn't matter if we're going counterclockwise or clockwise. Anyway, we would end up over here. The y value, this would be the point negative 1, 0. The y value is 0. The x value is negative 1. So 0 divided by negative 1 is 0. All right, negative 45 degrees, where would that put us? So if I start here and I go 45 degrees clockwise from 0 degrees or 360 degrees, right? If I go, 0 degrees really, because we haven't gone anywhere yet. We would say it's 360 degrees if we already went around full rotation. Okay, but anyway. So if I start here and go 45 degrees clockwise, then I would end up over here. Okay, and we can make a triangle out of that. 45 degrees, and if you remember the triangle from up here, each side was 1 over the square root of 2. Okay? So this would be 1 over the square root of 2. And this would also be 1 over the square root of 2. Actually, what I should do is I should erase this line. So we're really just talking about from here up to here now for these side lengths. Okay, from here to here and from here to here. So what would this point be? I'm not going to make the same silly mistake I did last time. So now let's actually focus on what we have that's negative and what's positive. So the x value of this point would be positive 1 over the square root of 2. The y value would be negative 1 over the square root of 2. Okay, and we're looking for the tangent here. Tangent would be the y value divided by the x value. So this divided by this would be negative 1, okay, because it's the same absolute value, but then this is negative and this is positive. So we're going to get a negative answer. So negative 1. Oops. Okay, negative pi over 2 for this one. Remember that pi over 2 is 90 degrees. So this means that starting from here, we're going 90 degrees clockwise since it's negative. And that would put us over here. So we're looking at this point. And since we're doing the cosine, we're looking for the x value of this point. All right, so this is the point 0, negative 1. We don't even care about the negative 1 because that's just the y value. For cosine, we just need the x value, which is 0. All right, negative 7 pi over 4. All right, so here's what we can do for this one. Pi over 4, you look at it, pi over 4, this would be 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, okay? So pi over 4 is the same as 45 degrees. So we just keep counting by 45 degrees, except since this is negative, we're going to count in the clockwise direction. So let's see here. Negative pi over 4, negative 2 pi over 4, negative 3 pi over 4, negative 4 pi over 4, negative 5 pi over 4, negative 6 pi over 4, negative 7 pi over 4. That would put us over here. So we're looking for the y value of this point over here. So this was, if I make this into a right triangle, then this is, you can see it's 45 degrees. We've done this a couple of times. Each side length would be 1 over the square root of 2. Okay, in particular, the y value here would be 1 over the square root of 2 positive, since we're going up. Okay, negative if we were going down for the y value. All right, so that's going to be 1 over the square root of 2. Oh, no, they don't want us to write it like that. Okay, so let's just take 1 over the square root of 2 and multiply it by the square root of 2 over the square root of 2, which would give us the square root of 2 over 2. Whoop, over 2. Right? Square root of 2 times the square root of 2 is 2. Okay, so that's how we're going to write it. All right, negative 11 pi over 6. This time we would, it's not this one over here. Okay, it would be the opposite. Well, what we could do, actually, if you go back to the previous example, you saw me go, forget about this for a second. A second ago, you saw me for when we had the sign of, what was it, negative 7 pi over 4. So what did I do? I went negative pi over 4, negative 2 pi over 4, and so on until I ended up here. Now you might have noticed that down here, this is positive 7 pi over 4. If I had gone counterclockwise, pi over 4, 2 pi over 4, 3 pi over 4, and so on, I would have gotten to positive 7 pi over 4 over here. This is really just like the mirror image of this one. Okay, so what I could have done for the last problem is I could have realized that if positive 7 pi over 4 puts me over here, then negative 7 pi over 4 would put me over here. Let's use the same reasoning for this one, because I see 11/6 pi over here. So if this is positive though, this is positive 11/6 pi. So if positive 11/6 pi is going to put me over here, then negative 11/6 pi should put me at sort of the mirror image of this, which is right over here. And if you were to count, that's what you would see, right? Negative 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5, 6 pi over 6 would just be pi, negative 7 pi over 6, negative 8 pi over 6, negative 9 pi over 6, negative 10 pi over 6, negative 11 pi over 6. See, so I didn't actually have to do all that. I could have just noticed that this is going to be the mirror image of this one. So this is the triangle that we're looking at. Okay, and this is telling us that is 30 degrees. Okay, everything is positive here. The x and the y values are going to be positive. So since they're both positive, we might as well just look at this triangle again. We're not going to get thrown off with any negatives like I did before. So we're going to look at this 30-degree angle, and what are we doing? Sine here. So sine is opposite over hypotenuse. So 1/2 divided by 1 would still just be 1/2. All right, I think that's good enough. All right, so you know what? I'm going to end the video there. I've probably given you the answers to like almost all the problems you're going to see. I don't know, who knows? Anyway, I'll end the video there and have a great day.